A plastic discovered 9,000 years ago, what you smear on the tip of your hammer in order to firm it up. Linseed oil, boiled in this case, also known as flaxseed oil. They were cultivating flax fibers 30,000 years ago, and somewhere around 9,000 years ago, they made a change in order to get bigger seeds and more oil out of it. That oil is a plastic. This is fascinating because we can meld the two understandings, ancient and artisanal understanding, with modern day chemistry to figure out exactly what's going on. If you look at vegetable oils in the ancient world, some dry and some do not. Olive oil does not dry. It'll go rancid, but it won't dry out. Sunflower oil kinda, sorta, semi-dries, and then linseed oil specifically boiled. And boiled doesn't mean they actually get it up to a roiling boil. They just bring it up to a certain temperature and then they add a seccative. That is something to dry it out from the inside out. Polymerize. Polymerize is something from the Borat movies. So how did they get ancient oil to plasticize without even knowing how? Oil is a hydrocarbon, a chain of carbon bound with hydrogen. Edible oil has a lot of fatty acids in it, which puts a hydrogen over here and an OH group over here. Now, in saturated fats, the dance card of all of the carbons is taken up by hydrogen. In unsaturated fats, sometimes there's a double bond with another carbon. They kind of, well, you know, I don't judge. And you can also have a triple double bond or a double bond, two of them in the same molecule, three of them in the same molecule. These are unsaturated. Now, a saturated fat or a hydrogenated fat, that is an unsaturated fat that they bubble hydrogen through in order to get it to saturate, it doesn't have any of these double bonds. They share two electrons. That allows this hydrogen bond to be quite a bit weaker, and it can pop off. Our favorite sailor Popeye has a penchant for olive oil. Olive oil contains lots of stearic acid, which has none of these double bonds. It's all saturated. Now, linoleic acid, which is linseed oil, has two of these double bonds in it. And another oil, tung oil, which is even more drying than linseed oil, has eleosteric acid, which has three double bonds. So these hydrogens are just waiting, shaking, champing at the bit in order to pop off there. And in order for them to pop off, they have to have some interactions with their electrons. You know what's really good at moving electrons around is metal. That's why we put metal into the linseed oil. We want to catalyze this reaction. So the hydrogen pops off. It takes oxygen out of the air. The oxygen goes on here. The oxygen is highly reactive. If you got two of these side by each, they polymerize together, and it goes from a liquid to a solid, and it can't change back into a liquid. It's been plasticized. This is also what happens when you season a cast iron pan. You bring the oil up to temperature, get these things shaking around, and free radicals pop off. You got an oxygen with an electron there waiting to grab onto other free radicals, form a polymer. That's that hard, waxy, greasy surface. That's why olive oil, a saturated fat, doesn't season pans very well, because it doesn't have any of these double bonds what can form a hang-ba-dang free radical in order to associate with other free radicals. So you want to use something like a flaxseed oil, fit for human consumption, but doesn't have any of those metallic ions what boiled linseed oil or tung oil have. Is science or JFM? Just fucking magic. It all amounts to the same. You got pixies dancing around here doing stuff behind the scenes, or linseed oil, it just chooches. Thanks for watching. Keep your dick in a vice.